All right. Rule number 5. You're up to 5 already.
What?
Okay. Yeah. How did we get to 5? Because the first one was how do you take the derivative of a constant? That was 0. And then the second one was how do you take the derivative of a linear function? And the derivative of that is just the constant. And then we finally did rule number 3, which was the power rule. And then rule number 4 was that the power rule could be added and subtracted to other power rules. Okay? So we've covered adding and subtracting. Today we're going to cover product, which means multiplication, and then we're going to cover quotient, which is dividing. So you already know adding and subtracting. We're going to cover multiplying and dividing.
Wait, was adding and subtracting when you take each individual point? Okay.
That you're allowed to treat each one as an individual entity, and then
Okay.
you do it one at a time. Okay, when you have a product, when you have 2 terms multiplied together, then there is a special rule. You don't just take the derivative of one and the derivative of other and multiply them together. Okay, there is a separate rule for how you take the derivative. All right, so here's how we go. So think of u is its own function. It could be a square root, it could be a parabola, it could be some kind of its own. And v is also its own function. Okay, so it could be, you'll learn a sine or a log, or 2 separate different functions. Multiplied together, how do you take the derivative? All right, it goes like this. You start with whatever v is. That comes first. Next to v, you multiply it by the derivative of u. So v stands alone, and then you multiply it times the derivative of u. You add to that the other combination, where u will stand alone, and then you're going to take the derivative of v. This is called the product rule. Okay? Now some people...
Oh, how come the u isn't written like inside the fraction?
It could be, for sure. Leibniz wrote it both ways. Okay, so you could, why won't it let me, nope. Okay, you could write it v times du dx, where the u is up there, and they mean the same thing. They're totally the equivalent. And u was written like this. Can anybody think of a different way I could write that? V times what? What would be a different way to write that? Prime, right? V times u prime plus u times v prime. That would all be the same too. Those are all the equivalent way of writing these derivatives, okay, using prime. Primes and d's are all the same thing. What it is not, just so we're clear, it's not v prime times u prime just multiplied together, okay? That is not the product rule, the rule for products. Okay, now the next problem I'm going to show you is a very, very easy problem, but I'm showing you that so we can practice before we move on to some harder ones. All right, so here we go. I call this easy because what's inside the 2 pieces? What's the kind of function inside the first parentheses? A linear, right? And then what's inside the second one? Also linear. So 2 linears is pretty easy to do. Okay, we're not talking about square roots, or we're not talking about, okay, but we're gonna practice this. Okay, so for df dx. So we start with, if this part is called part what? U, then this part will be called part v. And some books will call it part A and part B instead of U and V. I'm just trying to do what our book does. But notice that other calculus books will use A's and B's instead. Or they'll use F's and G's. The section F, the section G, like functions. Okay, which one do we start with?
V.
Start with V. So it's just 3x plus 4. Nothing different. We follow that by a multiplication of the derivative of part u, which is 2. Okay. Then we go back to part u, to u minus 1, to x minus 1. And then we follow that by the derivative of part v, which is 3. Okay, that's all the calculus that there is. So that was a pretty straightforward, easy example. Now you do have to simplify. So you'll take your your constants, and you'll distribute. So we end up with 6x plus 8, and then we take the other constant and we distribute, and we'll end up with plus 6x minus 3. So we're looking at 12x plus 5 as my derivative. And that will, yeah.
Does it also work to just FOIL it out and then take the derivative?
Okay, because these are two binomials, for sure. You could FOIL it out and you would get the exact same thing, okay?
Then when you get complicated, it's not as fun.
Yeah.
Okay, so who wants to FOIL a square root, right? Who wants to FOIL with like a log or a sine or, yeah, okay? All right, so that's why we started easy. Yeah. All right, we could FOIL these out. But my argument, I think, I'll hopefully convince you that the product rule is the better way to go. All right, so we have a cubic multiplied by a quadratic, okay, or a cubic multiplied by, you can call it a square. So find your f prime. Okay, what do we start with?
X squared plus 3.
X squared plus 3. Start with the quadratic piece. And then we multiply that. Good job, 3x squared. And you can use the dot, or you can use parentheses to show that you're multiplying. Okay, then we'll add to that, and we'll use the cubic piece, x cubed minus 4, and then we will multiply that by 2x. And then we do our distributing of each of those, and then we clean up if we have any like terms. So I'll have 3x to the 4th plus how much? 9x squared, good. And then plus 6x cubed minus 8x. So really the only way to mess this up, what did I do wrong? 2. Yes, I saw the 3. I wonder why that lets me do that. Okay, the only way you can mess this.
To the 4th. You're helping us know what mistakes we make.
I know. So I was just gonna say. So the only way you can make a mistake is by doing a dumb multiplication mistake. I was just demonstrating that for you. Okay. Yeah. Okay. Or make a dumb adding mistake, or make a dumb subtracting mistake. All right. So let's make sure I can add, and we'll have 5x to the 4th, and then 9x squared minus 8x. Okay. All right. Any questions so far about product rule? You're good, he says. All right. So then we're ready for the quotient rule.
Watch, it's the same thing except subtraction.
Almost. You're half right. Okay. So Rose says, watch, it's the same thing except subtraction. All right. So she's partially correct. Yes, you start with v again. And then you multiply it by the derivative of u, and then you subtract u times the derivative of v, and then besides the subtraction there is a division. Yes, but division is not hard. The division is simply the v quantities squared. Okay, now we're not going to get into today yet the proofs of why these things work and why these rules work, okay? You'll just have to take my word for it and wait for the day, which I'll prove it to you, okay?
Will you have to prove it ever?
Huh? No, I'll just for your own edification, okay? All right, so another way that people have written this is to call this, let's see, I'll do it in red. To call this the high function and the low function, and then to take the derivative of that. And so if you were to use high and low instead of u's and v's, what would we start with? Low times the derivative of high minus high times the derivative of low. Okay? All over the derivative of low squared. Okay. All right. So this leads me to a ridiculous little song that helps you remember to the tune of row, row, row your boat. Okay? So it goes low, 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 D high minus high, D low. That was it. The rest of it doesn't work. Okay, the rest of it doesn't work at all. But I passed Mrs. Cragness, and I'm like, I get to teach quotient rule today. And she started singing, low, 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 D high minus high, D low. So, yeah, something over, yeah. Oh, even though it would rhyme if you did over low times low.
Oh!
Because that's the same as low squared, right? Right?
That's our legacy.
All right, so we can make it go low, 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 D high minus high, D low. Merrily, 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 over low times low. That would work. All right? So, totally ridiculous, but maybe it will stick in your mind. Okay, so let's practice.
Yeah.
Okay, so anytime you have a quotient, okay, anytime you have a quotient, you identify, all right, that's my low quantity, this is my high, whoops, that's my high quantity, that's my low quantity, and you always start with low. All right, if you got it backwards and you started with the wrong thing, does it matter for product rules? No, because it's addition, right? But in quotient rule, if you get it backwards and you start with the wrong thing, you will end up with the negative of what you're supposed to have. So it's always a good thing too to check if you have a visual of a graph. Do I know if I'm on a negative section of the graph, or do I know if I'm on a positive section of the graph? It's always a good thing to double check to make sure that the sign of the answer you get makes sense with the drawing that you have, so that you're at least going the right direction. Okay, because if you get a negative answer, you should be on a part of the graph that has a negative slope. If you get a positive answer, you should be on the graph that has a positive slope. All right, so f prime, oops, or I'll do df dx this time, just to keep it different. All right, so we start with the low expression, so x squared plus 3, times the derivative of the high, so that would be 3x squared, minus, and then x cubed minus 4 times 2x. And then the whole thing is over the expression x squared plus 3 quantity squared. All right, we never simplify our denominator. Just like you are going to have, you don't have to do it with square roots to simplify, like rationalizing the denominator. You don't have to really worry about your denominator at all. Okay, we're going to focus just on simplifying our numerator expressions. All right, see if I can do my math here. So 3x squared plus 9, 3x to the 4th, 9x squared, minus 6x cubed plus 8x. You guys will have to just catch me if something's not right. What did I do now? 2, not 6. I did that. What is up with my brain that I'm seeing a 2 and a 3 and I make it? Okay.
Wouldn't it be, yeah,
To the 4th. I did the same thing, didn't I? The exact same multiplication. Something's not firing right in my synapses and neurons. All right, so we've got 3x to the 4th minus 2x to the 4th, so x to the 4th, plus 9x squared, plus 8x. This is all recorded for posterity too. This is great. Okay. All right. Do I need to slow down? We can move on to the next one. Hold on. Holding.
So wait, we just leave it like that?
Hmm?
We don't have to factor and reduce?
I could take the x out, but that's not going to help me.
Okay.
It is.
I know, it's such a...
Oh, don't be hating on our. All right. So now how do you apply that? Okay. Okay, find the locations of horizontal and vertical tangents. Okay, all right. So in order to do both of those things, I'm going to need the derivative because I need to know, okay, what kind of slope does a horizontal tangent have?
0.
Okay, slope of 0. All right, what kind of slope does a vertical tangent have? Okay, so, all right, come on, you can do better than that. It is determined. No, how steep is it? Okay, so what kind of slope does it have? Infinite slope, all right, so slope.
Maybe plus or minus. Where does it-
So it could be plus or minus infinity depending on which direction we're going, right? So if you're coming at it this way, then it'll be positive infinity. But if you were coming at it this way and coming, then you'll have negative infinity. So we can specify plus or minus infinity. All right, but either way, I need to figure out the slope first. All right, so we'll find our slope, which will be q prime. We start with x plus 3. We multiply it by the derivative, all right? The derivative being what this time? 2x minus 4. Ooh, so that's not going to be a nice little simple distributing. What's it going to be? Okay, minus, and then x squared minus 4x, and that will be multiplied by the derivative of x plus 3, which is what? Just 1. Okay, over x plus 3 quantity squared. Okay, so we'll do our FOIL. 2x squared plus 4x plus 6x minus 12 minus. All right. Then, now the 1 doesn't change anything, but so distributing the 1, but what else do I have to distribute? The negative. So that'll be negative x squared plus 4x. Okay.
Oh wait, there's an x.
There's a what? I think I'm okay. Hope
Yeah,
I'm
you're okay.
all right.
My bad.
Okay. So let's clean up these terms. Okay.
Ooh.
So my numerator, somebody give me yours. X squared. I get 6x because I've got a 4x here and a 4x here, leaving me only with, okay, and then minus 12 over x plus 3 quantity squared. Okay, that is the derivative, aka the slope. If I want to find the slopes of 0, that will bring me to the horizontal tangents. If I want to find the slopes of vertical, or the slopes of infinity, that will lead me to the vertical tangents. So let's find the slopes of 0. Okay, I'm going to move over on mine. What was it? X squared plus 6x minus 12. So x squared minus 6x plus 12. Wait. Plus 6x minus 12. Just copied them wrong. Okay. Over x plus 3 squared. If I want to find horizontal tangents, then I set this equal to 0. And I would always recommend, if you're setting a fraction equal to something, then make 0 a fraction also. And what would the denominator of 0 be? 1. Okay, the reason I like to do that, because as soon as I see a fraction on one side and a fraction on the other, my brain trigger, in a good way, goes, oh, cross multiply. All right, so we cross multiply. All right, the whole denominator goes away, and I have x squared plus 6x minus 12 by itself being set equal to 0. And that's why the equal to 0 part is important, okay? Because now I'm either going to factor if I can, or apply the quadratic formula, okay? Okay, can I factor this one? No. So then I will need the other song, x equals negative b plus or minus a square root b squared minus 4ac all over 2a.
If we have the quads program on our calculator, can we just plug it into that program?
If it's a calculator section, you're allowed to use programs. Okay, so that'll be 36 plus 48. all over 2.
Just add in.
Okay, 36 plus 48 is 84. Don't have to rationalize. Can't reduce the -6 with the +2 right now until you do something with the 84. You could simplify the 84, because 84 could be 2 rad 21. Then I could reduce that.
Oh, maybe I can do that.
Any equivalent answer?
So
Okay.
just leave it as ready for.
Sure. Yeah. Okay, now, how are we going to tackle the horizontal?
You
Okay, excuse me, the vertical. I said vertical. Okay.
said
All right. So x squared plus 6x minus 12 over x plus 3 squared equals plus or minus infinity. Well, if I wrote 0 as a fraction, how do I write infinity as a fraction? 1 over plus or minus 1 over 0. That's infinity. Remember we learned that, right? Okay. So instead of using infinity, use the fraction plus or minus 1 over infinity. So if horizontal is 0 over 1, vertical is 1 over 0. And then we cross multiply those. You don't? That's great. What do we get?
plus or minus x plus 3.
Okay, we get x plus 3 plus or minus squared equals 0. Okay, plus or minus 1. Okay, well, divide, if you don't like the plus or minus 1, divide by plus or minus 1. What's 0 divided by plus or minus 1? Still 0. Okay, 0 divided by anything is still 0 as long as you're not dividing by what other number?
0.
Okay, you can't divide by 0, but anything else. You can't divide by infinity either, sorry. But all right. Okay, so how do we solve that? No? Okay. What do I want to get rid of? I don't want a FOIL. I want to get rid of the square by applying the square root. Okay, that's x plus 3. What's the square root of 0?
0.
It's plus or minus 0. Be careful, because I don't want you to just say 0, because other times it might be plus or minus 2. All right, plus or minus 7. Okay, and then subtract 3. So this is -3 plus or minus 0, which is -3. But just, I don't want you to get into bad habits. All right, so my horizontal tangents are occurring twice at those two lovely square root options. And my vertical tangent is only occurring once at -3. I should have given you 2 slides for that. Okay, one more question. Any questions on slide 18? Okay, then let's finish this off. Okay, here's another way that the AP readers like to test to see if you know what you're doing or not. Okay? All right, so they're asking you to find the derivative. A is going to need what rule? Quotient rule. B is going to need what rule? The product rule. Okay, and then they're telling us to do it at x equals 5. All right, so they're checking, do you know that you need the product rule? Do you know that you need the quotient rule? What they are not wanting you to do is to plug in the numbers from right here right away. So the wrong way to do this would be to say, oh, I'm going to plug in u and v first. And u is 7, and v of 5 is 2. And the derivative of 7 over 2, because it's a constant, is what? That is incorrect. Because you're plugging in your numbers before you do the rule. The rule has to come first, and then you plug in your numbers, okay? Numbers always, the calculus rule always has to be applied before you plug in any values. So we're going to go back and say, no, that's not the right way to do that. The right way to do that would be for me to do low, 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 D high, minus high, D low, merrily, 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 oh, over low times low, okay? And then plug all your numbers in, okay? So then what are you plugging in for V? 2. And then what are you plugging in for the derivative of U? Okay, good. The derivative of U, which is right here, is the value of U prime at 5. The derivative of U is -3. And then minus, and then you plug in what you actually are plugging in for U, which would be 7. And then the derivative of V is 6. And then all over the quantity of V squared, which is 2 squared. So we end up with -6 minus 42 all over 4, or -46 over 4, which is very different than 0. Okay?
48.
I can add and subtract. Boy. You only teach one class a day and you get rusty. Okay. So let's think about this. What if you did these wrong? What if you put the numbers in first and did your calculus second? What are you going to get every single time? Yeah, there's no point. If you plug in the numbers first, you're going to get 0 for every single answer. Okay? So we're plugging in applying our calculus rule first. All right, so I wanted to show you B because we're throwing in what do you have with the number 10 out in front. Okay, what do you do if you have a constant in front of the problem? No idea. Okay? No. You can pull constants out to the front of derivatives. Okay, so this would become 10 times the derivative of uv. So your 10 is saved for the end and do all the work of your product rule. So my product rule says start with v and then multiply that by u prime and then add u and multiply that by v prime and save the 10 for the very end and multiplying your answer by what you would get. Because again, if you leave 10 in the inside and you do it all first, then your derivative is going to be 0 every single time because you're taking the derivative of 10, which is 0. All right, so we have v, which is 2. V, which is 2. U prime is -3 plus u is 7. V prime is 6. So 10 times -6 plus 42, so 360.
Ellie, Nancy, please go to